Welcome to another exploration of cutting-edge longevity science. I'm Your Name, and today we're diving into one of the most fascinating and accessible anti-aging technologies available right now, red light therapy. Imagine a treatment that requires no pills, no injections, no complex medical procedures, just light, specific wavelengths of red and near-infrared light that can penetrate your tissues and potentially add years to your life by triggering profound cellular changes. This isn't science fiction. It's called photobiomodulation, or red light therapy, and the evidence for its benefits is growing rapidly, from fruit flies living 175% longer to improvements in cardiovascular health, cognitive function, and tissue regeneration. Red light therapy is showing remarkable promise as a longevity intervention. In this video, we'll break down the science of how red light affects your cells, the compelling evidence from animal studies showing lifespan extension, the human clinical applications already in use, how you might integrate this technology into your own longevity strategy. Whether you're new to longevity science or a biohacking veteran, you'll walk away with a clear understanding of why researchers are so excited about this simple but powerful technology. So let's illuminate the path to a longer, healthier life. To understand why red light therapy works, we need to start at the cellular level, specifically with the powerhouses of your cells, the mitochondria. Mitochondria are responsible for creating the energy that fuels every function in your body. They produce a molecule called ATP, adenosine triphosphate, which is essentially the energy currency of your cells. As we age, mitochondrial function declines, leading to reduced energy production and cellular dysfunction. This is where red light therapy comes in. When specific wavelengths of red light, 600, 700 nanometers, and near-infrared light, 700, 100 nanometers, hit your cells, something remarkable happens. These wavelengths are absorbed by an enzyme called cytochrome C oxidase, which is a key component in the mitochondrial electron transport chain, the process that generates ATP. When cytochrome C oxidase absorbs this light, it becomes more active, which enhances the efficiency of the entire energy production process. Studies have shown this can increase ATP production by up to 80% in aged cells. This is significant because higher ATP levels mean your cells have more energy to perform critical functions like DNA repair, protein synthesis, and detoxification, all processes that decline with age. But the benefits don't stop at energy production. Red light therapy has multiple mechanisms of action that address fundamental aspects of aging. First, it optimizes reactive oxygen species, ROS, balance. ROS are unstable molecules that can damage cells when present in excess, a condition known as oxidative stress. While some ROS are necessary for cellular signaling, too many accelerate aging. Red light therapy has been shown to reduce excessive ROS production by making the electron transport chain more efficient while simultaneously boosting antioxidant defenses. Second, it reduces inflammation, particularly the chronic low-grade inflammation known as inflammaging that's a primary driver of age-related diseases. Red light therapy downregulates nuclear factor kappa B, NF-κB, a master regulator of inflammatory pathways, thereby reducing the production of pro-inflammatory cytokines. Third, it enhances tissue repair and regeneration. Red light stimulates fibroblasts, cells responsible for producing collagen and other structural proteins. This leads to improved skin elasticity, faster wound healing, and better recovery from exercise and injury. Fourth, it improves blood flow and microcirculation, ensuring better oxygen and nutrient delivery to tissues throughout the body. And finally, it stimulates the production of stem cells and growth factors, which are critical for tissue regeneration and repair. All of these mechanisms work together to address what researchers call the hallmarks of aging, the fundamental cellular and molecular changes that drive the aging process. By targeting multiple hallmarks simultaneously, red light therapy offers a comprehensive approach to slowing aging at its roots. The evidence for red light therapy's impact on longevity comes primarily from studies in model organisms, where the results have been nothing short of remarkable. Let's start with fruit flies, Drosophila melanogaster, which are commonly used in aging research because they share many aging pathways with humans. In a groundbreaking study published in the Journal of Gerontology, researchers exposed fruit flies to daily sessions of 670 nanometer red light and found that it increased their ATP concentrations by 80%. Even more impressively, it extended their average lifespan by 175% compared to control flies. To put this in perspective, if similar effects could be achieved in humans, we'd be talking about potentially adding decades to the human lifespan. Of course, we can't directly translate results from fruit flies to humans, but these findings are significant because they demonstrate the potential of this technology. Moving up the evolutionary ladder, studies in mice have also shown promising results. Research published in 2023 found that regular exposure to near-infrared light extended median mouse lifespan by 0.6-1.0 months, which would be equivalent to about 2 to 3 human years. More importantly, these mice showed reduced age-related pathologies like heart failure and stroke. A 12-month study demonstrated that daily exposure to near-infrared light reduced age-associated inflammation in cardiovascular and neural tissues in mice. The treated mice showed delayed frailty and improved gait symmetry, both indicators of healthier aging. They also exhibited attenuated cardiac aging, including reduced left ventricular wall thickness and improved aortic elasticity, which are markers of prolonged cardiovascular health. What's particularly interesting about these findings is that they involve conserved mitochondrial pathways across species. The same cellular mechanisms that respond to red light in fruit flies and mice are present in human cells as well, suggesting that the benefits might translate to humans even if the magnitude may differ. Beyond direct lifespan extension, red light therapy has shown effectiveness in delaying or mitigating age-related diseases. For cardiovascular disease, the leading cause of death worldwide, red light therapy improves ATP production and reduces inflammation, which slows cardiac remodeling in mice. These effects could potentially reduce the risk of heart failure and other cardiovascular complications in humans. For neurodegenerative conditions like Alzheimer's and Parkinson's, emerging evidence suggests that red light therapy may protect against cognitive decline. By enhancing cerebral blood flow and reducing neuroinflammation, it has improved cognitive function in aged mice and reduced amyloid beta plaques in Alzheimer's models. Even for cancer, while not directly studied for carcinogenesis prevention, red light therapy's antioxidant effects may reduce DNA damage linked to malignancies. However, it's important to note that red light therapy should never be used as a primary cancer treatment without medical supervision. These findings raise an important question. If red light therapy can impact so many aspects of age-related disease, could it potentially extend human lifespan? While we don't have direct evidence yet, the biological mechanisms and animal data strongly suggest it's possible. While we await long-term human lifespan studies, red light therapy is already being used clinically for a variety of conditions, giving us insight into its potential benefits for humans. Red light therapy is FDA cleared for several applications, including acne treatment, wound healing, and pain management. These approvals provide a regulatory foundation for its use and demonstrate its safety profile. In dermatology, red light therapy has shown impressive results. A clinical trial involving 90 patients receiving 8 red light therapy sessions over 4 weeks reported 90% or greater improvement in skin texture and wrinkle reduction. Beyond cosmetic benefits, this enhanced dermal integrity also fortifies the skin's barrier function, reducing infection risk and environmental damage. For musculoskeletal conditions, the evidence is equally compelling. A 2023 trial on musculoskeletal pain reported a 50% reduction in discomfort after just 4 weeks of red light therapy. Athletes using red light therapy have experienced 40% faster recovery times and reduced muscle soreness after intense training, which may contribute to sustained physical activity, a known longevity factor. Some healthcare providers are now integrating red light therapy into comprehensive anti-aging protocols. For example, longevity clinics combine red light therapy with other interventions like nutrition optimization, exercise, and stress management to address multiple aspects of aging simultaneously. It's worth noting that while these human studies are promising, most are relatively small, fewer than 100 participants, or lack rigorous placebo controls. Additionally, the optimal dosing, including wavelength, intensity, and treatment duration, varies across devices and applications, complicating protocol standardization. Despite these limitations, the human data we do have aligns with the findings from animal studies, suggesting that the cellular mechanisms observed in model organisms are indeed active in humans as well. If you're interested in incorporating red light therapy into your own longevity strategy, there are several approaches to consider. First, let's talk about the different types of devices available. Professional-grade panels are large devices typically found in clinics, spas, or high-end gyms. These provide full-body exposure and use precise wavelengths with optimal power output. Sessions on these devices usually last 10 to 20 minutes and may cost anywhere from $30 to $100 per session. Home panels are smaller versions of professional units that can be mounted on a wall or door. While less powerful than clinical models, they offer convenience for regular use. Prices range from $300 to $2,000 depending on size and specifications. Targeted devices include handheld wands, masks, and small panels designed for specific areas like the face, joints, or small muscle groups. These are more affordable, often ranging from $50 to $300. When selecting a device or treatment protocol, several parameters are important. Wavelength. The most effective wavelengths for cellular benefits fall between 600 to 850 nanometers. Specifically, red light, 600 to 700 nanometer, and near infrared, 700 to 850 nanometer, have shown the strongest evidence for mitochondrial activation. Irradiance. This measures power density, typically expressed in milliwatts per square centimeter, MWCM2. Effective treatments generally use 10-100 MWCM2. Treatment time and frequency. Most studies use daily or every other day treatments lasting 5 to 20 minutes, depending on the power of the device. Consistency appears to be more important than duration. Distance from the device. This significantly affects the irradiance reaching your tissues. Follow manufacturer guidelines, but generally, 6 to 12 inches is appropriate for most panel devices. For optimal results, here are some best practices. Expose bare skin directly to the light as clothing blocks the beneficial wavelengths. Start with shorter sessions, perhaps 5 minutes, and gradually increase as your body adapts. Be patient and consistent. Like exercise, the benefits of red light therapy accumulate over time with regular use. Consider combining red light therapy with other evidence-based longevity interventions such as exercise, proper nutrition, quality sleep, and stress management. Some researchers suggest potential synergies with supplements like NAD+ boosters, such as nicotinamide riboside, or senolytics. As for cost considerations, while high-end devices can be expensive, more affordable options are increasingly available. Even budget-friendly devices can provide benefits if they deliver the correct wavelengths, though treatment times may need to be longer to compensate for lower power output. Before concluding, it's important to acknowledge the limitations in our current understanding of red light therapy for longevity. First and foremost, we lack long-term human lifespan studies. While the animal data is compelling and the biological mechanisms make sense, we don't yet have direct evidence that red light therapy extends human lifespan. Such studies would require decades of follow-up and are challenging to design and implement. Second, optimal protocols remain uncertain. The dose of light therapy, combining wavelength, intensity, duration, and frequency, likely needs to be personalized based on age, health status, and specific goals. More research is needed to establish standardized guidelines. Third, individual variation in response exists. Factors like skin pigmentation, tissue thickness, and pre-existing conditions may affect how much light penetrates and how cells respond. Some people may benefit more than others from the same treatment protocol. The future research agenda for red light therapy and longevity should prioritize several key areas. Large-scale human trials with appropriate controls and long-term follow-up are essential. These studies should track biomarkers of aging like inflammatory cytokines, oxidative stress markers, and telomere length. Comparative effectiveness research to determine which wavelengths, intensities, and treatment schedules yield optimal results for different applications and populations. Combination therapy studies to explore potential synergies between red light therapy and other interventions such as exercise, dietary approaches, and supplements that target complementary pathways. Mechanistic studies to further elucidate how red light therapy affects the fundamental processes of aging at the molecular and cellular levels. Looking ahead, we may see integration of red light technology into everyday items like lighting systems, wearable devices, or even implantable technologies that deliver precise doses of beneficial wavelengths. As our understanding improves, so too will the sophistication and accessibility of the technology. Red light therapy represents a paradigm-shifting approach to longevity, targeting fundamental aging mechanisms at the cellular level. By enhancing mitochondrial function, reducing inflammation, and promoting tissue repair, it holds promise for extending health span and potentially lifespan. The most compelling evidence comes from animal studies showing significant lifespan extension, along with improvements in age-related biomarkers and disease processes. Human clinical applications, while still evolving, demonstrate benefits for skin health, pain reduction, and tissue regeneration, all factors that contribute to healthier aging. What makes red light therapy particularly exciting is its non-invasive nature, relatively low cost compared to many medical interventions, and growing accessibility. It doesn't require prescription medications, has minimal side effects when used properly, and can be incorporated into almost anyone's routine. As research advances, red light therapy may become a cornerstone of integrative anti-aging strategies, offering a non-pharmacological path to healthier aging. While we should maintain appropriate scientific skepticism and await more human data, the current evidence suggests this technology is worth serious consideration for anyone interested in optimizing their longevity. Thank you for exploring the science of red light therapy with me today. If you found this information valuable, please give this video a thumbs up and consider subscribing for more evidence-based content on cutting-edge longevity science. Have you tried red light therapy? I'd love to hear about your experiences in the comments below. And if you have questions about implementing this technology or other aspects we've discussed, drop them below and I'll do my best to address them in future videos. For those interested in diving deeper, I've included links to key scientific papers and resources in the description. And don't forget to check out my related videos on mitochondrial health and other non-invasive longevity interventions. Until next time, here's to illuminating the path to a longer, healthier life.